Thank you very much. So I've decided to talk a bit about space mobility and propulsion. I chose this title specifically because I think that there's no reason why one day we should be able to talk about mobility in space. Just as we worry about mobility topics on ground, one day we should be worrying about space mobility for sure. And there's a lot to be done. But before I get there, just a quick overview of the space activities that at ESA we've been looking at. And now what you see here are 4 pillars of activities that the European Space Agency deals with. The first one is linked to science and exploration. So we look into the secrets of the universe and the solar system, and obviously we have robotic and astronaut exploration. We have a pillar called safety and security, and I'll get back to that in a second. We have applications, which is everything about Earth observation, navigation, and telecommunications. That, in my view, are customers that require propulsion needs. And then we have what we call enabling and support, and we see here space transportation system operations and technology development. Indeed, I believe that there's 2 fundamental enablers of space activities at all, and one of them definitely is propulsion systems. Now, the safety and security pillar deals with safety and security in and from space. In space is everything linked to space weather. Exciting topic. If you've never heard about it, definitely look into it. Space debris and asteroids, and then we have safety and security from space, which has to deal with providing services to deal with disaster management and elements of the sort. Rapid response for resilient human activities. Now, when I think about the future of space, as I said, I'd like to think that one day we're really going to worry about space mobility. And what you see here is a set of pictures of what I think is going to happen in the future. So we're going to be certainly taking objects into orbit. We're going to be worrying about taking them back down when we don't need them anymore. But there's so much stuff that's going to be going on in orbit. So we're going to be manufacturing objects in orbit. We're going to be assembling stuff in orbit. We're going to be moving from one orbit to the other, from one planet to the other. So that's why I talk about mobility. We'll be doing stuff on moon, on planets, on the moons of planets. And all of this is going to require some sort of propulsion mechanism. So again, propulsion certainly is at the core of all of this. Now, it would be remiss of me not to talk about debris. There certainly is something that needs to be done with regarding to debris. If we don't deal with the the high number of objects that is up there in space, we won't be able to continue our activities in space. And I don't know if you guys have been following a bit the news. There was one, very sad accident or incident that occurred just the other day, where a satellite was shot down. This caused another 1,752 objects of debris to be created. And you probably heard that the astronauts that we have on the International Space Station had to go and hide in their capsules so that they're not endangered. So this sort of thing, of course, is very sad. And we definitely need to act responsibly in space. So it has to be sustainable what we do. Now, there's obviously an upside to dealing with space traffic, and that is, we see that the business in space is not just something that is being triggered by nations, but it's certainly something which has economic success. And this is going to be more and more so the case. So we see lots of assets that were launched this year in space with Starlink and many other constellations that are up there, OneWeb, and there's many more to name, including lots of startups that are looking at this. And the number of satellites is going to increase. And I certainly see that there's a need for us to, have a space traffic management awareness and regime that will allow us to have a vibrant circular economy in space. And again, space propulsion for me is at the core of all of this. Now, we've certainly seen that there's a wide diversification of platforms that has been going on in the past years, and smaller satellites are becoming more and more interesting. I think this is fundamental to be pointed out, because on the one hand, it enables businesses to develop something in a way which is more affordable. But on the other hand, we also see that there's a niche of smaller satellites, CubeSats, nanosats, that at this stage don't really have propulsion systems. So for me, there's also a niche to be addressed there for sure. And I know that there's a number of companies, big and small, that are looking at this for sure. But again, this is where propulsion systems can certainly be an enabler for future elements. Propulsion concepts, there's so many propulsion concepts. I find them all absolutely fascinating. I personally come from the chemical and specifically liquid propulsion systems. I know today is going to concentrate mostly on the electric propulsion, but there's things that remain unexplored. And I do hope that, you know, one day we will see research picking up speed and, you know, these elements actually happening. I mean, it would be fantastic at some point where we could really have, for example, antimatter propulsion. Absolutely amazing how much energy you could release with that sort of physics. When we think about propulsion systems, I think there's fundamentally different ways of thinking what you can do in the future. I'm showing this slide, Starship. I think everyone knows what SpaceX has done and what Falcon 9, Falcon Heavy represents in the good and the bad, and what Starship, the developments around Starship. Now, I think this concept is very interesting. What they've done is fantastic, but I think that there's also a system view that needs to be taken when we look at propulsion systems. And this is why I've taken this picture up, because certainly Starship with the big Raptor engines, liquid oxygen, liquid methane, a huge thrust and propulsive force that they have, they're amazing for sure. But one thing that when I look at this, I keep on wondering is, you know, we do have an atmosphere as a planet. So why aren't we using more of this atmosphere to make these systems more efficient? If you're completely winged, of course, you have a bit of an impact on your structural weight, so that might not be very efficient. But to use just propulsive force, I think that's also not very efficient. So stepping back and looking at things from a system point of view, I think is very important when we look at propulsion systems and when we think about systems of the future. I mentioned CubeSats. Now here we see one CubeSat that with a propulsion system that has been developed for this kind of satellite. But there's other systems that are actually being researched. We see here schematics of an water electrolysis propulsion system, which is being looked at, where you just basically have water, you send it through an electrolyzer, and then you have hydrogen and oxygen which you burn in a thruster. And these kind of systems, as I said, would really address the niche of satellites that we're seeing also develop, which on the one hand can be a big business case, on the other hand will contribute and are partially already contributing to increasing these number of satellites in orbit, debris that then become debris. I absolutely find amazing this whole topic of in-orbit servicing, and what's associated with it is what we call close proximity operations. Of course, this requires a different set of skills and technologies. And I think that there's a range of elements that can be developed as well to make, as I said, everything that's going to happen around manufacturing, assembly, and in-orbit servicing happen in the future. I think I'm going to skip this slide in an elegant way, because this is going to be the topic in a sense of one of the talks, but not necessarily this specific system. But again, going back to the element of making use of our atmosphere, developing air breathing systems for very low orbits is something which I find is extremely clever, because it brings together, it's a marriage of different concepts to optimize the resources that we have. And so I find that fascinating. I'll be looking forward to the presentation for sure. Another thing I find absolutely fascinating is the concept of planetary mobility. So propulsion systems and how they can help us in the future to explore planets like Mars, for example, that actually has an atmosphere. So here we see the little helicopter Ingenuity, which was put on Mars by NASA. And again, I think that such systems can be very cleverly deployed for planetary exploration, planetary mobility. And this is certainly where space propulsion systems can also play a strong role. It would be remiss of me not to talk about advanced manufacturing and materials. When we talk about propulsion systems, I find this also an extremely fascinating topic, because we can fundamentally think of the systems that we implement and we design in different ways. We have here an example, again, liquid propulsion, because that's my background, of a combustion chamber, which is a lot more compact. It has an aerospike nozzle at the tip. And this has been possible because of 3D printing, right? So you can actually conceive and make things happen, which previously would have been extremely hard to manufacture. Now, when we think of everything that's going to happen in space, one of the things that I certainly find interesting is thinking about the lifetime, and not just the performance, but the lifetime of things that we will be developing. And the first experiences that we had in space propulsion in general on lifetime was certainly the Space Shuttle main engine experience. So I'm just going to share that as an example. Obviously the Space Shuttle main engine, very high thrust engine, so not representative of everything, but throughout its lifetime, the engineers figured out that there's some components that are, of course, more critical than others to the lifetime of the system itself. And these are the actual thrust chamber and the turbo pumps, which are used to bring the propellants into the combustion chamber. So one of the things I'm trying to say here is we look at propulsion systems from a system point of view. We try and then look at the propulsion system as a whole when we consider what niches are going to be needed are going to be needed to be filled in the future. But then we can also start looking into components individually. And from a liquid propulsion point of view and from the reusability point of view, we can start certainly thinking of the lifetime. And just to give you an example, just to dive deep briefly, here is the cut through of a combustion chamber of a liquid rocket engine. You see the different elements: injection dome, the injector elements. You have the actual chamber volume with a whole lining structure, and what you see here are the cooling channels. And I don't know if you're all aware, but the cooling channels, they go through some significant thermomechanical cycling. And one of the things that happens is because of on the one hand, thermomechanical loads, but also aerodynamic erosion because of hot and high speed hot gases in the combustion chamber. What happens is that the cooling channels, what you see here on the right, they go from being squared cooling channels, they go from being rectangular to having this sort of doghouse kind of effect. And what happens is that the cooling liquid that's supposed to cool the combustion chamber then actually flows into the combustion chamber. It's kind of a self-healing mechanism, but obviously it's not that good. And what I'm trying to say here again is we do see lifetime effects. And this is one of the things, for example, that we would have to consider in liquid propulsion systems to be fixed. Another one is the turbo pumps. I mentioned it, just to give you a feeling for those of you that are not into turbo pump elements, we have temperature ranges that go from 20 Kelvin to 900 Kelvin. And for example, in a liquid hydrogen turbo pump, and we have rotational speeds that can go up to 90,000 rotations per minute. So it's quite big, and the pressure ranges can go from 2 to 500 bars. So there's a number of components where we can certainly deep dive and try and improve them. And obviously this applies to electric propulsion as well. One of the recent missions that we launched is Bepi Colombo to Mercury, which is an absolutely fascinating mission in my view. And one of the most intensive testing was lifetime testing that was done on the electric propulsion systems on board this mission. And I was just trying to read up before joining this webinar to see what the lifetime issues of electric propulsion are, and I just happened to fall upon an article of Nature that goes on talking about materials and how materials can be used to improve the performance and also lifetime of possibly next generation electric propulsion systems. One of the things that I picked up was self-healing structures, which I find also absolutely fascinating. So there's so much to be done, both from a system perspective, down to deep diving into material properties and performance of individual elements. And for me, the last topic that I just like to share with you is magic happens when you then bring multidisciplinary approaches to look at space elements. And one of the things that I'm trying to push forward is predictive condition and health monitoring and predictive maintenance possibly as well. And I find this topic absolutely fascinating, and I think it's at the core. If we really want to be out there in space and doing all of this fantastic stuff that can happen in space, then at some stage we're going to have to really think not on one-off missions, but really in long term. And we're going to have to start looking at things like, as I said, predictive condition monitoring and maintenance, which is already happening in many other sectors like aircraft and other elements as well. So that was my quick 15 minutes, you know, from the big system into the deep dive. And I'm going to be looking forward to the rest of the presentations. And of course, I'm here for answering any questions about technical, non-technical, policy, and whatever else. So happy to be with you.